Yeah, so welcome to the Global TA webinar. My name is Julia from the Institute for Technology Assessment and Systems Analysis in Germany. My colleague Marlene is also here from the Rathenau Institute. She's also part of the team, the core team that kind of coordinates these webinars. So we're really excited to have you all here today. I think it's a new record for registration, so we're very happy. For those of you who don't know, the Global TA network is a worldwide network of people and institutions working in the wider area of technology assessment. This can be understood quite differently, but we won't go into that. I also invite you to join our LinkedIn page. I've put that in the chat, where we post regular news also about the webinar. So you're welcome to join that if you haven't yet. We also have a YouTube site for these regular webinars where you can watch them or pass them on to your colleagues afterwards. So yeah, welcome everyone. Today we'll learn about TA and quantum technologies. So I'm very excited about this. And as a kind of interactive part, we thought it would be nice if you can put in the chat where you are at the moment, maybe what time it is. We know Lei is already late in the evening, but you can add that, and whether you actually know what quantum technologies is. You don't have to answer what it is, but maybe yes or no answer. I will not be testing you on this, so don't worry. Just to get an idea of who knows what it is, and so please feel free to use the chat for that. Today we have two of my ITAS colleagues here. I'm very excited to have talked them into this. So Zeki and Adrian, thanks for being here today. Short introduction, Zeki, you've been at ITAS since 2021, and you've worked in various projects concerning quantum technologies, such as focusing on military use, but also issues of trust in science and research. Strengthening grassroots communities in quantum technologies. I thought that was quite interesting, but also questions of how are quantum technologies imagined and envisioned. So quite relevant questions, I would say, for TA. Adrian, who's also here today, is a physicist. He's been at ITAS since 2023. He also works in different projects, also looking, for example, at quantum technologies and military use, but also innovation surrounding quantum technologies, focusing on potential threats, but also social benefits. And also using methods such as responsible research and innovation. Yeah, that was the word, in the development projects. And I think you guys just got a new project from the German Ministry of Research, Technology and Space, also on quantum technology. So maybe we'll hear about that as well. And yeah, I'll hand over to you. From my side, that's it. We'll have the presentation about 15, 20 minutes, and then we'll have some time for discussion afterwards. So over to you, Adrian and Zeki. Thanks.
All right. Hi, everybody. I'm going to share my screen, and Zeki is going to start.
Yeah. And well, first of all, it's great to be here, and it's also very exciting and a bit daunting to see all the names in the participants screen, and just hi to everyone who knows us, and nice to meet with everyone who we haven't met before. So yeah, as very graciously introduced by Julia, I'm Zeki, and today we will have a relatively short presentation with Adrian on our work at ITAS on technology assessment for quantum technologies, insights, outcomes, future directions. We are truly looking forward to the discussion part of this webinar, so we will try to be a bit quick. So next slide, please. And when we were preparing this presentation, we kind of discussed, okay, what is our motivation for this particular webinar, with the global TA community. Of course, it's always nice to interact with different communities, but, why do we want to particularly interact with this community now? And one of the main reasons that we could think of is 2025 was the International Year of Quantum Science and Technology by UN, and there were, I mean, more than 1,000 activities around the world and quite a bit of interest in the topic, awareness raising. And following that, there is now a formation towards a global quantum initiative under UNESCO that will focus on sustainable development goals. And since this is a global effort, and we are TA researchers, it's sounded very fitting to kind of also inform you of this and just get your opinions and basically discuss this with you. So next slide, please. At ITAS, we are primarily working on quantum technologies, but as everybody knows, Armin in the TA community, so he's our institute leiter, and he coordinates these activities, so he doesn't necessarily do the research himself. And then we have Christopher, who's our group leader at Light. Is basically more hands-on, but still doesn't necessarily engage that much with nitty-gritty of the research. So mostly it's Adrian and me that is getting involved in this. So if you have any questions or you want to collaborate somehow, I think it would be easier for you to reach out to us, instead of Armin or Christopher, but of course feel free to do so as well. So what we do do a lot of different things, as again introduced by Julia, but primarily we do landscaping, education outreach research, looking at the policy aspects of dual use, technologies in quantum technologies, art science interaction, cultural relations, let's say, to quantum technologies and this newly developing quantum arts community. Yeah, so next slide, please. So the agenda today is, as I said, we will try to be quick. I will briefly talk about what we understand from quantum technology. So basically what we mean by quantum technologies when we are talking about this topic during this presentation. Then a few insights from our work. And then Adrian will take over to talk about the outcomes of our studies, especially the ministry report we prepared last year, and then the future directions. And then we are looking forward to the discussion. So when we say quantum technologies during this presentation, what you should kind of understand is we are trying to talk about a particular set of technologies which are usually referred to as either quantum technologies or second generation quantum technologies, because technically speaking, things like transistors or lasers, they're also quantum technologies. They use quantum physics principles. But the reason why we are focusing on the second generation is that in the quantum, so to speak, the quantum world, the world of very small, elementary particles, there are certain principles such as superposition, entanglement, uncertainty principle that until a couple of decades ago, it was very difficult to actually control or manipulate on quantum levels. And with the advancements in cryogenics and control electronics and optics and photonics, these became more easily accessible to actually work on as physical phenomena. And then there's a set of technologies that are called quantum technologies that are building on these principles. So the main idea of quantum technologies is, any kind of technological approach that kind of manipulates these quantum principles. That's why there's this, word quantum in front of a lot of the things you see. So next slide, please. And in the European context, it basically clusters into four pillars: communication, computation, simulation, sensing, and metrology. In the US context, they combine computation and simulation. And I think in the European context as well, we will it's getting more and more combined. Like when you look at infrastructure projects like EuroQCS, it is European Quantum Computing and Simulation Infrastructure. So basically, we can say that there are three pillars. So one is focusing on communication, one is focusing on computation, and one is focusing on sensing, imaging, and metrology. Next slide, please. And so these technologies are not necessarily new. They're not old either. But like the relative hype on these goes even back more than a decade. You can see that like the D-Wave device, it was on the Times cover, and then like several science covers. Again, Time, a few Nobel Prizes. So this it has been around for quite some time. So this is not something entirely new in the media and the public domain. But what is new is, Adrian, so the next slide, please. Oh yeah, so this is the International of Quantum. And yeah. So what is new is actually the amount of interest in the topic. And the reason why we are getting involved in it, from a TA perspective is that, I think this is very, like the TA researchers in us, like it's very similar, it's very familiar to you, but for the folks who probably came from the more quantum side of, this TA for QT webinar, there's this thing called the Kolmogorov dilemma in the TA, literature that dates back to 80s. So basically, the argument here is that in an earlier stage of a technology, it is easier, or you say you have a higher probability or possibility of control. It's not guaranteed. So even if like you really want to, you might not succeed in controlling the trajectory of a technology, but you have a higher possibility of control in an earlier stage. But the problem is you have basically no evidence or very little evidence of impact, or especially societal impact, in an earlier stage. So what you want to do is you want to find, this relative sweet spot where you have enough evidence, but you still can impact the trajectory of these technologies. And that's basically why we are involved in quantum technologies from a TA perspective. And in the field, how this translates to actual research questions is, for example, for quantum computing. So everything you see on the screen is a different kind of quantum computer. So like there's one on superconducting qubits, there's one on silicon, one on ion traps, one on neutral atoms, one on photonics, and nobody knows which of these will be the dominant design of the futures for quantum computers. So basically, the transistor of the quantum computers, it's not settled yet. So there are a lot of different potential futures, and this means that depending on these futures, there will be different societal impact, or different environmental impact, different economic impact. So there's a lot of potential futures, let's say, and that's why getting involved in this early stage is actually quite helpful, because we can track why these decisions are being made, what are the priorities of different stakeholders, and is there room or need for certain kind of interventions or not. And as I said, one thing that is new in the field, especially, is the amount of funding from public sources. So the estimate is something like 50 billion euros globally, but it is primarily concentrated on 3 regions, which is not surprising. So like North America, Europe, and China. And of course, if you also include Japan, India, Singapore, others, like Asia is quite strong in this domain. But again, as you can see, there's clearly a divide between certain more developed regions, economically especially, compared to Africa or Latin America, or the places like Philippines, for example. And what, like very quickly, what we do, so this was our flagship project, which is still ongoing actually under POF Helmholtz project initiatives. So basically under this, what we have done was we did quite a bit of landscaping, so startups, patents, publications, investment, all that stuff, education and outreach research, and something we call ELSA research, so ethical, legal, social aspects research on quantum technology. So it's a mouthful, but basically it covers things from conceptualization of like democratization, trust, readiness, how these can be applied to TA research on Qt. And as also mentioned before, so we are part of this active TAP project under the German Parliament that is focusing on military use of quantum technologies, but the focus is not to how to make quantum bombs, but basically what are the implications of new possible military applications of these technologies for peace and security policy aspects. So it's not just landscaping what is available out there. And also, as you mentioned, there was this 1-year project with our partners at TU Delft, primarily supported by the Center for Quantum and Society of Netherlands. So we organized a summer school with grassroots initiatives from around the world. I think there were 17 countries involved, and there were quite a few of global follow-up events in different regions and continents. And the focus was basically bringing people together from all around the globe to discuss these, ethical, legal, social aspects issues of quantum technologies. And as another example of this, for example, we organized something in Singapore 2 years ago on the impact of geopolitics. Yeah. And with that, I leave the floor to Adrian.
Thanks, Zeki. Yeah, I take over. Thanks for this overview. I try now to get a very small but deep dive into our TAC project, so Technology Assessment of Quantum Technologies. And I don't know who read it. I mean, it's in German language. It has an English executive summary. And I would say currently, everyone knows the tools how to translate such a report, but it might not have been on your desk due to the rather German title. But I would say this is okay, I did it together with Zeki and others, but I would say it's a well-done study on different aspects which are relevant for quantum technologies from the technology assessment perspective. And what we did here, to give you some brief overview about the methods, was, of course, we reviewed the literature, but we did extensive interviews with experts, and I'm very happy actually about the experts we got for this study. Very, very well-known people, plus a survey. And we also did some workshops, so we had kind of, I would say, mixed methods in here. And the workshop was rather about the visions and futures of quantum technologies, which are also in this report, but not so much in my brief presentation right now. If you're interested in this, ask later or check the report. There have been several questions which have been asked in this study, and they have been given mainly by the ministry and were added with topics from us. So we, of course, looked on what is happening in technology assessment of quantum technologies. We looked on the impact of quantum computing on IT security, on sustainability aspects, security implications, consequences of unequal access, so the quantum divide, societal implications, the discourse, unintended side effects, and other, and these are mainly the ones we also wanted to cover. I will just briefly tap into 3 of them, but you see there we had a mouthful of different aspects we wanted to cover in the study, and therefore I'm very happy actually about the experts we were able to interview. Quick one on the status quo. This is a graph not from the study actually, but one could easily say, okay, this is one of the first studies in this field when it comes to technology assessment. I mean, there are others before, but not that many, and one has to say. And this is a slide Zeki likes to use, and I also really like. When you look on responsible AI versus responsible quantum, which of course is not directly technology assessment, but has some overlap, one sees roughly at least factor of 100 in between the number of publications. And here, of course, until 2024, but one can already see, okay, with quantum technologies, we're earlier in the development when it comes to assessing societal or other impacts. And there's more to do. Let's leave it like that. But when we go more into detail, you can already give some answers. So the first one I want to briefly mention also, because maybe everyone heard about, but for the ones who didn't hear about, I would say this is very important, the security aspects. So how could especially quantum computing affect IT security? And there we got quite some agreement between the experts that quantum computers are evolving rapidly. So the estimates are in the 2030s, we're going to have a cryptographic relevant quantum computer. All the roadmaps are met in terms of development of the quantum computers, and even some experts said acceleration is possible, which leads us to problems like, okay, the Shor algorithm might be implemented, and then we actually get problems with our current encryption system. But there's also the problem of store now, decrypt later. So there's a threat for infrastructure, and one needs definitely measures against it. And the most prominent and maybe easy one is like the PQC implementation. So post-quantum crypto is something which everyone needs to be aware of. So also you, especially the ones which are maybe not from quantum in this call, this is something what should be aware of. We're gonna get, if we don't deal with it, gonna get some problem with our encryption systems. But as this is maybe known, I want to go over to the quantum divide and talk about what Zeki mentioned a bit, connected to the different investments globally and also different consequences due to it. And this is like connected to several of the topics here, like security implications, but also like societal implications. And there are actually different outcomes from this study. So the first one could say, okay, there's a global quantum divide. Different countries and regions invest different amounts. That leads to geopolitical advantages of some, which even might be used by others. So if like a certain region is not having the same possibilities, some other entity might use it. And therefore, a lot of experts said, okay, we still need, of course, still need international collaboration, but also strategic investments. And now this is from a German/European perspective. So please keep this in mind. But having this rather European perspectives in the study, a lot of experts also told us that there might be some dependence on non-European actors, especially for quantum computing. And this gives Europe, although investing heavily in quantum technologies, the risk of losing some advantage or someone else using a quantum advantage. So when, for example, big US companies are leading this field, Europe might even be depending on non-European actors. So again, from European perspective, strategic funding, European integration, IP security is important. And I feel this is also for globalTA perspective very interesting that this is an outcome from this study. And another one, when it comes to quantum divide, the local quantum divide is interesting. Zeki also has a paper on this. You can ask him also. But that certain people in communities might not understand it or don't have access to quantum technologies as others, and we might get a backlash. We might get talent shortage, unequal access, etc. So information education is definitely important, even within societies who have large funding in quantum technologies. So that's so far on the second aspect I wanted to mention. A third one I'm going to give now are other impacts, which from a TA perspective might be interesting. So unintended side effects, because there is, on one hand, people say, okay, there are some things which are like in the future, which might happen. So we might get problems with resources. There might be some dual use risks, one could say. There might be unintended consequences, which in the long run might need strong ex post regulation. So people fear that. At the same time, some other experts said, okay, unintended side effects are inherent, unpredictable, so we can't do anything. And they actually fear overregulation, so that we do too much in this early phase in terms of regulating quantum technologies. And adding to that, some other experts said, okay, there's co-evolution with other technologies, so there might even be some acceleration. Just think about quantum and AI or others, so acceleration is possible. And this is what a TA expert, of course, always can say. We need continuous monitoring, timely detection, communication of emerging risks and opportunities. But I would say, coming from this Collingridge dilemma perspective, this is, of course, important to do. So taking these three examples, I want to give you a brief overview about like future directions we're thinking about. Coming from that quantum technologies are different. So we have different kind of quantum technologies. They are also developed at different stages. So different quantum technology readiness levels, which need various TAA approaches, for example, included in our study. There are geopolitical shifts happening and also new applications. So, for example, military TA or environmental aspects need to be considered, which, for example, Zeki told us are done in this one study we just shared. Then we have like an early stage of quantum technologies still with some possible dynamic evolution and a lot of like hyping and other stuff around. So we might need also different things like hermeneutic TA, which is, for example, my PhD topic. And QTs are globally developed, so we need like participatory elements where the community is involved. For example, Zeki shared something on this. So I know that, okay, this is all important and we do all of this. So is everything good? One could say. Are we dealing with everything? And there, Zeki and I, but also other colleagues would say, okay, there is, for example, a growing quantum technology community. So this is good on one hand, of course. At the same time, we somehow need to increase the people, like we need to handle this from a TA perspective, how we get these different voices involved, the different developments, and so on. From European perspective, we are currently struggling a bit like the European integration of the TA institutions. So how can we, as now in Germany-based people, integrate our work together with other TA institutes in Europe? So this is an ongoing debate, and how can we also integrate our expertise in current developments, for example, around the Quantum Act and the globalTA. So there is a quantum divide. There are UNESCO or UN developments and things going on. At the same time, there seems to be less acceptance for this multinational organizations. So this overall global developments, of course, doesn't stop here. And there are, of course, a lot of unknowns one should consider. Therefore, there's a lot to do still and a lot to discuss. We can discuss in a minute. And I would just end with like two examples of things we are thinking are important for you or for others in the field. I said, okay, TA of quantum technologies is an example of the variety of TA approaches which are needed due to several reasons I just gave you. I can just click through this. Connected to, of course, an overlap with other technologies. So I'm also very interested in like if there are practitioners from other fields, what could we learn from you? Technology-wise and TA-wise. So we would say quantum technologies are actually a test bed for TA research itself. Not just we need to apply it, but also we can learn something about TA while applying it on quantum technologies. At the same time, we have this like global development and increase in people in quantum technologies with the problem from a European perspective to integrate it. But also on the global side, it's the question, how can we like adjust and include somehow all these different developments? So there's a question of, should we somehow globally institutionalize the TA research on quantum technologies while keeping regional differences? Because like, of course, different regions have different needs in this. So this is just a thought maybe for the discussion, but there's definitely a lot to learn with quantum technologies about TA, but also other way around. So thanks for listening and let's discuss.